All right, section 2 is all about dividing monomials. So we have a couple exponent rules that we want to look at while we're kind of discussing dividing our monomials. So the quotient rule tells us that we can divide two powers with the same base by subtracting the exponents. So x to the m power divided by x to the n power equals x to the power of m minus n. And this is only true as long as x does not equal 0. That's kind of an important fact about that. So one way we can look at that, or one way we can kind of prove it or see it, is 4 to the 5th power divided by 4 to the 2nd power. It means we have 4 times 4 times 4 times 4 times 4 on the top, and 4 times 4, just two of them, on the bottom. Well, two of them from the top cancel out with two of them on the bottom, so it's kind of like a hidden times 1 over here, because we still have all of this times 1 on the bottom. So it's 4 times 4 times 4 over 1. So 4 to the 3rd power over 1. Anything divided by 1 is just itself, so that's why we're left with just the 4 to the 3rd power. So that'll be our quotient rule. Our zero rule. According to the zero rule, any non-zero number raised to the power of 0 equals 1. I'm going to show you kind of a quick reason why. If we have 2 to the power of 1, remember that just means 2 times 2 times 2 times 2 times 2, but there's only one of them, so that would just be 2. 2 to the power of 2, so it's 2 times 2 times 2, and there's only two of them. 2 times 2 is 4. 2 to the power of 3 would be 2 times 2 times 2, which is 8. I'll do one more. 2 to the power of 4 equals 2 times 2 times 2 times 2 becomes 16. Notice how each time we go from here to here, we're doing times 2, times 2, times 2 to get here. So what if we went backwards? What if we tried to go next to 2 to the 0th power? Well, going from 16 down to 8, we're dividing by 2. Same thing, 8 to 4, 4 to 2, we're dividing by 2. So if we do another divide by 2, 2 divided by 2 is 1. So that's why anything to the 0th power has to be 1, because all of those, any number to these powers will follow this pattern. So anything to the 0th power equals 1, and this will help explain our next rule, the negative exponents. What if we kept going and I went 2 to the negative 1? Well, 1 divided by 2 is 1 over 2, or 1/2. 2 to the negative 2 means 1/2 divided by 2 becomes 1/4. 2 to the negative 3 would be like 1/4 divided by 2 is 1/8. Okay, and if you write all these down kind of in between these, this will kind of be a good visual, kind of help you see what is happening and what's going on with all of these. So this proves our zero property, the zero rule. Anything to the 0th power is 1. As we keep going down, dividing by 2 each time, this helps us see that the last rule in this lesson tells us any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. So notice, 2 to the negative 1 is 1 over 2 to the 1. 2 to the 1 is just 2. That's where this came from. 2 to the negative 2 is 1 over 2 to the positive 2. 2 to the 2 is 4. So that's where this 4 came from. 2 to the negative 3 is 1 over 2 to the 3. And 2 to the 3 is 8. So 1 over 8. So this pattern here, multiplying by 2 every time you go up, dividing by 2 every time you go down, that pattern kind of helps us prove both the zero rule and the negative exponents. So that's why both of these ones are true. So let's look at some examples of this. Example 1, we're looking at quotients of powers. Remember, you always cancel out on top and on bottom for these. So I'm going to kind of rewrite this. A to the 3rd, B to the 5th, all over. If there's no exponent there, it's like an A to the 1st, and B to the 3rd. Well, if we do b to the 5th divided by b to the 3rd, that would leave us with b to the 5 minus 3 is 2. Same thing with this a to the 3rd and a to the 1st. 3 minus 1, so whatever's on top is being divided by whatever's on bottom. 3 minus 1 is 2. So the answer to A would be a squared, b squared. Remember, as we kind of cancel out 1 from here, cancel out 1 here, gives us 2. 3 from here gives us 2. We still have a times 1 down here. So it's all of this over 1, which is just itself. That's why it kind of ends up just as being this number over 1. And you can just say this piece. All right, let's try the same thing with b. If we have 4 x to the 1st power, y to the 7th power, all over 2x to the 1st power, y to the 3rd. Okay, 4 divided by 2 would just be 2. We can break 4 up into 2 times 2, cancel out the 1, 2 on top, 1 on bottom, so we would just have 2. Cancel, cancel, I'll kind of rewrite in the 2 there. X to the 1 and x to the 1 cancel out. So it's like we have an x to the 0th power, but remember x to the 0th is just 1. 2 times 1 would still be 2. So we really don't even need that part. They just cancel out and we're done. Y to the 3rd, take 3 away from there and 3 away from here. This is now y to the 4th. So this would be y to the 0th, which is just 1. We don't need it anymore. So all of this times 1 on bottom. So we're left with on top 2 and y to the 4th all over 1. We don't need the over 1. Anything divided by 1 is itself. So it's just 2y to the 4th. Let's do C here. We have x to the 3rd, y to the 4th, over x to the 2, or x squared. And just y alone means it's y to the 1st power. Same thing. We can just cancel out on top and on bottom. If we take away 2 from here and 2 from here, that leaves us with 1. Take away 1 from here and 1 from here, that leaves us with 3. If we took out these 2, this would just become x to the 0th, or 1. This would become y to the 0th, or just 1. So on bottom, we have 1 times 1, which remember is just 1. On top, we have x to the 1st power and y to the 3rd power. Remember, anything to the 1st power is just itself, and anything divided by 1 is itself. So we just have x, y to the 3rd power. This would be the simplest way to say this, or to simplify this fraction, would be x times y to the 3rd power. Last one, we have k to the 7th, m to the 10th, and p alone, so it's p to the 1st, all over k to the 4th, m to the 4th, and p alone, so it's p to the 1st. Take out 4 from on bottom here, and that kind of cancels the whole thing out. 4 from up here turns this into a 3. 4 from the bottom and 4 from the top make this a 6, and this one cancels out. Take out 1p from on bottom, and that takes out every p from on top, so we no longer have p. P divided by p is just 1, so it's like they both cancel out. So remember, we still have a times 1 on bottom, so it becomes k to the 3rd, m to the 6th, all over 1. But we really don't need that divided by 1. Anything divided by 1 is just itself. So this answer comes out to k to the 3rd, m to the 6th. So that would be dividing our powers. We're just canceling out on top and on bottom. For powers of a quotient, okay, so we have all of this to the 2nd power. We're applying each power, we're applying this power to each of the factors. So this 2 gets applied to each thing individually. So we go 2 with the 3, 2 with this p to the third power, and 2 to the 7th. So we would have 3 to the second power, which would become 9. We have p to the third power to the second power. Remember, power to a power property from our last video means we multiply them, would become p to the 6th power. It's not p to the third plus 2, it's p to the 3 times 2, so p to the 6th. And this 2 also gets applied to the 7. So 7 squared, 7 to the second power, is 49. And we can't simplify that anymore. We can't take anything out of the top and the bottom. So this is our final answer. It would be 9p to the 6th power over 49. Same thing. If we have 3x cubed y to the 6th all over 2z to the 9th, all of that to the 4th power, the 4 gets applied to each piece individually. So we'd have 3 to the 4th power, which would actually be 81. We'd have x to the 3rd to the 4th power. This 3 times 4 then becomes x to the 12th power. Same thing, we'd have this y to the 6th to the 4th power. So all of a sudden it becomes y to the 24th power. 6 times 4 is 24. All over 2 to the 4th power is going to be 16. Z to the 9th to the 4th power means we do 4 times 9. So we have it z to the 36th power. And again, we can't take anything out of the top and the bottom at this point. So this is as simple as we can make that one. This would be your answer. Couple more examples here. 3x to the 4th over 4, all of that to the 3rd power. Well, the 3 gets applied to each piece individually. 3 to the 3rd power is 27. X to the 4th to the 3rd power becomes x to the 12th. 4 times 3 is 12. All over 4 to the 3rd power, so 4 times 4 times 4 is 64. Again, we can't do anything to simplify any of these things. We can't simplify 27 64ths. Can't get rid of any of the numbers. We don't have any negative exponents to get rid of, so this is our simplified answer. Last one. 4x to the 3rd over 5y to the 4th. All of that to the 3rd power. 4 to the 3rd power becomes 64. X to the 3rd power to the 3rd power. Oops, I didn't mean to click there. 3 times 3 becomes 9. So we have x to the 9th power. All over 5 to the 3rd power is 125. Y to the 4th power to the 3rd power, this one on the outside. 4 times 3 is 12. So we have y to the 12th power. Okay, these are all x's. We'd have 9 x's being multiplied here. We'd have 12 y's being multiplied. So we can't do anything, any sort of canceling out here. We can't take out any numbers. 64 over 125 is as simple as it's going to get. And we can't take out any of our variables. So this is our simplified answer. All right, now we're looking at the 0 exponent. Remember, anything to the 0th power is 1. So in our first case here, all of this to the 0th power. There's a couple ways you can do it. You can think of, like before, this 0 gets applied to each piece individually. So 10 to the 0th is 1 times u to the 4th to the 0 would be u to the 4 times 0. So u to the 0, which would also be 1. V to the 3rd to the 0, 3 times 0 is 0. V to the 0 is 1. and w to the 9th to the 0, 9 times 0 is 0, w to the 0 is 1. Okay, if we continue this pattern, you'll notice each thing, it's just 1 times 1 times 1 times 1. All of this over all of this would, in the end, equal 1 over 1, which equals 1. Okay? A more simple way to do that is think of this whole thing as being a number. Whatever number comes out on the inside of this parentheses, if we take that number to the 0th power, anything to the 0th power is 1 right there. So in the end, that is our answer, just 1. If you ever have all of this in parentheses to the 0th power, you can just instantly, you don't have to do any work, you just know for sure it is 1. Let's look at example B though. Here we don't have the whole thing to the 0th power, it's just the y to the 0th is 1. So we'll set it up like one of our quotient of powers. We have x to the 5th over x to the 3rd. This y to the 0th just becomes 1. And we don't really need this times 1 because x to the 5th times 1 is still just x to the 5th. So we can get rid of that piece. So now it's just x to the 5th over x to the 3rd. And we remember how to do that. We take away 3 from down here and 3 from up here. Leaves us with x squared, not x to the 5th, x squared over 1 because this became x to the 0th. So it's just 1. X squared over 1 equals x squared. So this would be your answer. Similar thing down here in C. We've got a to the 3rd, b to the 2nd, c to the 0th, all over a, b. We'll start off by writing each piece individually. A to the 2, or a to the 3, sorry, b to the 2. C to the 0th is 1. Oops, that's supposed to be times, so 1. All over a to the 1, b to the 1. If they don't have an exponent, it's like it's to the 1st power. Okay, we don't need this times 1. Times 1 doesn't change anything, so we can get rid of that piece. To divide these exponents then, take away 1a, so this became 2. Take away 1 of the b's, so this became 1. Remember, all of this is now still times 1 on the bottom. It all became 1. So it's a squared times b to the 1st power all over 1. We don't really need this all over 1, so it just becomes a squared times b to the 1st power. But you don't have to write in the b to the 1st power. Anything to the 1st power is just itself. If you want, you can write it in, that's fine. But you can write it easier by just saying a squared times b. So all of this monomial would be your simplified answer from C. And D is going to be a lot like number 1. We have all of this to the power of 0. So no matter what this answer comes out to be, we'd say the whole thing just equals 1. Nice and easy. Zero property. And last set of examples. We have negative exponents to look at. Now, whenever you have negative exponents, you just move the exponent to the opposite side, to the top or to the bottom. So like in example A, we have n to the negative 5th power. We're going to say right away, let's move that down here. N to the positive 5th power. Instead of on top, it's now on bottom. Same thing, we had r to the negative 2 power. Let's move that one up. So it's r to the positive 2 power. P to the positive 4 will stay here. P to the 4th. So now we've kind of rewritten our problem so that we have all of our positive exponents, no negative exponents allowed. And at this point, we only have r's, p's, and n's. Nothing can cancel out. So this is as simple as this one is going to get. Basically, all we did was get rid of those negative exponents by moving it from the top to the bottom. Okay, let's try example B. 2 will stay on the top. If we look at our a's, though, I might as well do both numbers, 2 and 10. If we look at our a's, we have negative 3 here, and we have positive 2 here. So we need to move this negative 3 to the top. When you move these 3 to the top, it's like you're adding those 3 on. So instead of a to the 2, it's a to the 2 plus these 3, so it's a to the 5th power. And I got rid of this on the bottom. Same thing with b. Instead of this b to the negative 1, we move 1 up to the top. Get rid of it on the bottom here. There was already 3 of them here, so now there would be 4, b to the 4th power. You're just kind of moving them from the bottom up to the top. You're adding that 1 on here. The last variable you have is c. We have negative 5 on the top, c to the negative 5th power, c to the positive 4th power down here. So we need to add the 5 from the top to the bottom. We get rid of it up top here, call it c to the 9th on the bottom here. So now we have 2 a to the 5th, b to the 4th, over 10 c to the 9th. Now it might seem like we're just about done here, except 2 over 10 we can reduce to 2/10 is the same as 1/5. 1 over 5, we can divide both of them by 2. And we don't need this 1 here. 1 times a to the 5th, b to the 4th. We can kind of get rid of that 1. So on the top we would just have a to the 5th, b to the 4th, over, we still need this coefficient of 5, c to the 9th. And this would be our final answer then. This is our simplified version of this fraction. Okay, let's try example C here. We have v to the negative 2 on top here. We have y to the negative 5 on bottom, so those are going to have to move. V to the negative 2 on top becomes a v to the 2 on bottom here. We'll leave our w and x squared untouched and our w here. And to make it easier, we might call it w to the 1 and w to the 1. This y to the negative 5 moves to the top, becomes a y to the positive 5. Okay, so this was the first step in kind of getting rid of our negative exponents here and simplifying it. We just changed everything to a positive by moving it to the other side. Now, the last step is we have w to the 1 on top and on bottom. We can cancel those ones out, which would leave on top we have x squared y to the 5th over v squared. Okay, and we can't simplify or divide out anything else because none of these variables match. It would just be x squared y to the 5th over v squared. That would be all the simplifying you can do. Last example, D. 32 and 4 need to stay. We have an a to the negative 8 and a to the 3rd. Add the 8 from here down here. 3 plus 8 becomes 11. A to the 11th on bottom. B to the 4th, B to the 6th. They're both already positive, so we'll leave them as they are. C to the negative 5th, C to the negative 2. Those both need to flip. We'll put the C to the 2 up here, C to the 5th down here. So now we have nothing but positive exponents. So at this point, we look at 32 divided by 4. Well, that's the same as 8 over 1. So when we write out our next piece of the fraction, we'll put 8 on top. And we don't really need a 1 on bottom because 1 times anything would be itself. So that would stay as it is. We don't have any a's to cancel out here, so these a to the 11th will just stay there. We have 4 b's on top and 6 b's on bottom. So if we take out 4 from here, take out 4 from here, okay, I don't think we've seen this before. We're actually canceling out the top ones and putting them all canceling out of the bottom ones. So we got rid of the b's on top. So now we would just have b squared on bottom. And that's okay. You can cancel out the ones on bottom, or the ones on top, get rid of the ones on the bottom then and leave them down here, as long as it's a positive exponent. Same thing then, we have c to the 2 and c to the 5th. Take out 2 from here and 2 from here. That leaves us with c to the 3rd power. So I'm actually going to move this 8 over just so it's centered. In the end, our answer is 8 over, oops, we don't need a negative, 8 over a to the 11th, b squared, c cubed. And that would be as simple as we can make that. And that should be the end of all of our examples.